This is an introductory video on getting started with BlackRock's offline sorting software, or BOSS for short. If you don't have a copy of BOSS, you can download a demo version from our website that includes all of the features of the full version, but without the ability to save your sorted file. This tutorial will cover the basic workflow of BOSS, from the opening of a file to saving your sorted results. When you first launch BOSS, you'll be presented with a file dialog for selecting the file that you would like to load. I'm going to select my NS5 file, or 30 kilosample per second continuous data, so that we can take a look at how BOSS works with continuous data and spike extraction. BOSS has no limits on file size, so I'm going to select a large file to work with to demonstrate some of the features that BOSS has in dealing with large files. Before we look into too much detail in this screen, it is important to note the BOSS workflow. Many spike sorting programs are extremely confusing, overloaded with features that are generally not used, and this leads to very confusing workspaces. BOSS presents spike sorting in a series of simple steps, during which it attempts to show you the information that is most relevant to that step. Right now, by looking in the upper left, we can see that we are in the detection step. It is during this step that we will manipulate our continuous data, and then extract waveforms. With that, let's take a look at some of the windows that BOSS has presented us with. One window that will always be available is the Channels window. This window contains each of the channels found in our data file and allows us to look at a number of stats for each of them, such as the number of detected waveforms, the length of the data, applied filters, and some BOSS-specific statistics such as sorting method used and waveform categories. Selecting a channel in this window determines which channel we are working on in our workspace. Another window that is always available is the Timeline view. The timeline allows us to look at the continuous data, or extracted spikes, in their time-stamped order. The final window that we will utilize frequently is the Options tab. This tab contains some of the BOSS controls that are used in that step of spike sorting. In this case, we are presented with options for filtering and thresholding, both things that are necessary to extract spikes from this continuous data. The two windows that are specific to the detection step are the continuous frequency spectrum and the peak heights histogram, both of which give an overview of the contents of the continuous data as a whole. The order of the contents of the option window is a suggestion to the order in which spike extraction is generally completed. The first step is to choose how we would like to filter our data. I am working with simulator data, so pretty much any filter will work well for me, but this is something that you can tweak when working on your own data to see what works best for you. We have the option for high-pass filtering the data, and the additional option of attempting to extract based on signal energy. For each option, we have a few different parameters that we can change. For the high-pass filtering group, we can select the filter type. It is up to you to determine which filter works best for your data, but I'm going to choose the default Butterworth, since that is the filter type that the neural signal processor utilizes. At that point, we have the option of changing the cutoff frequency and filter order, or steepness of the cutoff. Let's leave the filter order at 4, but let's change the cutoff frequency a little bit. We can change it here on the Options window, or we can change it on the continuous frequency spectrum. Now that we have high-pass filters covered, let's talk about signal energy. If we choose signal energy, we would get presented with two additional plots, signal energy over time on our timeline, and the waveform energy histogram as part of our peak heights histogram plot. The signal energy selection has a few parameters that allow you to select the type of energy plot, as well as the bin size for calculating energy. For now, let's disable signal energy and stick with a simple high-pass filter for the rest of our extraction. The next step is thresholding, deciding at which level a signal must pass to be counted as an action potential. By default, BOSS is set up for a single threshold. This is a bar that a signal must cross to be extracted as a spike. You can adjust the threshold here, or you can change it on the timeline, or even the peak heights histogram. The ADC counts refers to the digital value of our conversion, BlackRock's 16 bits combined with their ADC range to give a 250 nanovolt resolution. Thus, each ADC value represents a quarter of a microvolt. By enabling dual thresholding, it allows us to threshold waveforms on either side of the axis. In this way, we can capture waveforms that are primarily negative or primarily positive deflections. By default, we can choose a different value for each threshold, or we can force them to be symmetrical using the checkbox. My simulator data is quite symmetrical, so we don't necessarily need a dual threshold. So we'll just go ahead and take that away. If we were using signal energy, we could use this to select the energy threshold. Finally, we can set our threshold automatically, based on a calculation of the noise. Generally, somewhere from 3 to 6 is a good range for setting your threshold as a multiplier of the noise RMS. But let's stick with our single threshold for now. The very last options in the extraction step are selecting the waveform properties. These control how many data points make up an extracted spike, and how many of those are before the threshold crossing and after the threshold crossing. You can also control the refractory period for triggering threshold crossings. These are currently set similar to the default settings for the neural signal processor, so I will leave them as they are. At this point, our data is filtered and our threshold is set, so we are ready to detect. Click Detect and BOSS will begin working on the data file. If you are working with a large data file, the extraction may take a little bit of time. Fortunately, BOSS makes excellent use of modern processors and will allow you to begin working on another channel with no performance loss while one finishes extracting. You can see the blinking status on our channel 1 showing that it is processing. Unfortunately, it was too fast for me to be able to make much use of this feature, but for extremely large files, it can prove very useful. We can see that BOSS shows us the number of waveforms that we extracted. And now we are ready to move on to the next step, sorting. If we had loaded a data file containing spike data instead of continuous data, this is the screen we would start on. In the sorting step, we are presented with a variety of new windows. We have 2D clusters, 3D clusters, feature versus feature, a waveform view, and a units view. It is very easy to move windows around, nest them, or adjust their size. For example, I prefer to have all of my cluster windows, my 2D clusters, 3D clusters, and feature versus feature plots, on the same tab, so that I can keep my waveform views constantly visible. If you are working on a multi-monitor setup, you may find value in breaking the windows out using this symbol here at the top of the window. Well, let's put it back for now and delve into sorting. In the Options window, we are presented with a matrix of a number of feature pairings. Each of these pairings is shaded to show the clustering tendency. A darker shade indicates a higher clustering tendency, meaning that the feature pairing is more likely to yield a plot that allows us to resolve unique units. The 4 best pairings for clustering tendency are selected by default and shown on the feature versus feature plot. At this point, we can select our sorting method. BOSS has methods that range from fully automatic to completely manual, and everywhere in between. I am particular to performing an automatic sort and then manually editing the results. The 2 sorting methods available for BOSS at the moment are T-distribution expectation maximization and K-means. You can read more about these methods in the manual, but since K-means is probably the most familiar, we will use that one. K-means is a recursive algorithm that attempts to reach a convergence point as it is repeatedly recalculates centroid positions. The first thing to do with K-means is to select the number of clusters, or units, that you think exist in the data. In my simulator data, it is quite clear that there are 3 separate units when we look at the various feature versus feature plots. I will move clusters to 3, and then we can click Sort. Each of the clusters becomes color-coded based on its unique unit assignment. We can see that each of these waveforms is colorized for every view that it may appear in. If, instead, we want to make the algorithm a little less automatic, we can provide suggested centroids to the K-means algorithm using the Define button. By looking at the 3D clusters plot, we can see that it is in clusters mode, allowing us to define centroid positions by holding down Control and clicking on what we feel is the center of our 3 clusters. With the centroids defined, we can click Sort again and see a result similar to what we saw earlier. With our waveforms automatically sorted, it is often nice to go through the data and clean up any units that could have been mislabeled by the algorithm, or to clean out noise units that we have ended up recording. Since we don't need the Options window anymore to do this, I'm going to dismiss it by clicking Options. I'm also going to change the size of my points to make it easier to see separate waveforms in my PCA space. Now this data, being simulated, is really quite clean, so there's not much to clean up. If I see any stray waveforms, such as these ones here, which look more like noise to me, I can select them in any of my views. In my 2D clusters view, I can circle it, or I could highlight it in my waveforms view. With a waveform or waveforms highlighted, I can right-click and select from a number of options. I can change the unit that this waveform is assigned to, I could make a new unit, or I could invalidate the waveform if effectively removing it from the dataset. Let's invalidate it, since it appears to, potentially, be noise. Even without highlighting a waveform, the option to delete a given unit definition is always available. To make sure that there are no noisy or mislabeled waveforms that I have missed, I'm going to quickly hide some of my units to check my waveform view. Everything looks good, so let's end our session here. If we were finished with our file, we could go into the File menu and select Save to save it as an extracted spike file with sorted units. But I plan to continue working on this editing session at a later time. Luckily, Boss saves my work automatically, so even though I'm in the middle of working on this continuous data file, I can stop anytime and pick up where I left off later. This session covered the basic use of BlackRock's offline spike sorter, BOSS. We covered the basics of extracting waveforms, and sorting spikes, and editing with manual methods. In later sessions, we will cover more options for manually editing files and additional data views. Thank you for joining us today for this tutorial. Be sure to stay tuned for additional videos on BOSS as we continually add new features. For additional information on any of our products, manuals can be found at www.blackrockmicro.com.